Okay, welcome back. I'm going to go through some harder examples of log expressions, log manipulations. I'll call these test style examples because they're good questions to ask on a open book math test or math exam for this course. We're told the following information. We're told that the ln of a plus b is equal to 5, and we're told the ln of c minus a is equal to 16. We're not asked to solve for a, b, and c. We're asked instead to find the value of a related expression, the ln of a plus b to the 3 divided by the square root of c minus a. How on earth are we going to do this? Well, what we have to do is we have to use log properties to manipulate the expression. We're going to manipulate the expression until we have the ingredients that were given to us. We're trying to extract ln of a plus 5, or ln of a plus b, and we're trying to extract the ln of c minus a. We're trying to turn what we have here at the bottom into some combination of what we were given. So the first thing I'm going to do is I'm going to use the ln of m over n property. The ln of m, I'll call it log property. Log of m over n is equal to the log of the top minus the log of the bottom. So I'm going to rewrite this expression as the ln of a plus b power 3 minus the ln of c minus a power 1/2. I'm also going to convert the square root into a fractional power. Okay, now the next step is I want to bring those powers down. So I'm going to use this property, the log of m to the n is n times the log of m. So the 3 is going to come down, 3 times the ln of a plus b. The 1/2 will come down, 1/2 times the ln of c minus a. And now we can use the information that we were given up above. The ln of a plus b was told to us at the start. We were told that ln of a plus b was 5, so 3 times 5. And we were also told that ln of c minus a is 16. I'm going to replace this with a 16. And then simplify. 15 minus 8 is 7. And that'd be your answer. So it's not hard to do once you know how to do it. So the general template is you're given some data. You're given that data in kind of a transformed format. You want to manipulate those transformations so that you can pose that expression in terms of what you were given. Here's another example. Very similar style. This time instead of log, it's exponentials. You're told that 8 to the power of a plus b is equal to 27, and 2 to the power of c minus b is equal to 3, and you're asked for an expression that's kind of related to those. You gotta solve the puzzle. How do you manipulate what you're given here to express it in terms of the 8 to the a plus b is equal to 27, and the 2 to the c minus b is equal to 3? How do you do that? Okay, so let's first compare pieces. I'm looking at this piece, the a plus b and the a plus b as partners, and this set, the c and the b, as partners. I'm going to have to somehow write 2 to the a plus b in terms of 8 to the a plus b. That's not impossible, because 2 can be written as 8 to the 1/3 to the power of a plus b. And then the second piece, I'm going to write this using the exponent law as 2 to the power of c minus b all squared. So what happened for that second one was the following. b to the m all to the n is b to the m times n. I use that rule. So 2 to the 2c minus 2b is equal to 2 to the power of 2 times c minus b, which is 2 to the c minus b all squared. We're going to have to do something similar for the first term. For this first term, b to the m to the n is equal to b to the m times n, but that's also equal b to the n times m, since the order doesn't matter, which is equal to b to the n all to the m. And this is the first time you've seen this property, but b to the m all to the n, if it's just those two things multiplied together, m times n, that must be the same as b to the n all to the m. You can just interchange those powers. You just change the order. And that's what I'm going to do in the first term. I'm going to write this as 8 to the a plus b all to the power 1/3. Minus 2 to the c minus b all squared. Now I'm going to substitute in the data. 8 to the a plus b is 27. 2 to the c minus b is 3. And now we can simplify. 27 to the power 1/3 means cube root 27. 3 squared is 9. So I have 3 minus 9, which is -6. And that is hard. That's a challenging problem. You have to know your exponent laws and look for opportunities to use them. Another example, so you're not always asked to solve for x. You're not, in this case, asked to solve for x. Instead, we're being asked to solve for 1 over x. So I'm going to start by isolating for the exponential function. I'm going to subtract 7 from both sides. So e to the minus 1 over x is equal to 8 minus 7. E to the minus 1 over x is equal to 1. Now I want to use the cancellation law to get the exponent all by itself. That means taking the log of both sides and use ln to match the base of the exponential. So ln of e to the negative 1 over x equals the ln of 1. And the ln of 1 is 0. We have a cancellation law here on the left. So negative 1 over x is equal to 0. Multiply both sides by negative 1. So 1 over x is equal to 0. That's it. That's the answer. Because again, we were not asked to solve for x. If you're asked to solve for x, it's undefined. There is no x value that does this. Here's another one. Here we're not asked for x, we're asked for x divided by 1 minus x. Asked to solve for that. And our expression doesn't directly involve x over 1 minus x. We have to create it. And we're going to create it by using a log property. Notice that if we use a log property, the log of m minus the log of n equals the log of m over n, what we'll get is log base 3 of x over 1 minus x is equal to 2. So we almost have what we want. We just have to get it out of the log function. To get out of the log function, we're going to exponentiate, raise both sides as powers on the same base. As powers on 3. Using 3 to match the base of the log, so we have the cancellation law. So x over 1 minus x is equal to 9. That's it. Don't do anything else. Because sometimes we don't want x. Sometimes we want some other part of the expression. Okay, and that's the end of this video. Test style examples.